Alright, before we start using oscilloscope as a curve tracer, we always make sure everything is good to go. I've got everything plugged into the internal square wave generator, and I've pressed auto set. Something you should see though is that this is set to 20 and that's set to 2, and that's because this has a gain, and the switch is over here and it was set to 1000. You have to pull it back, all right, otherwise it won't work. So it seems a lot of the ones have that. So now if you look, the scale is off and we've lost trigger. We'll do auto set, right, and we'll set up acquire high res, and I'm just going to zoom in. Okay. And so I'm going to do the blue trace to compensate. And you can see there's some overshoot here I just can't get rid of. And also we'll find there is a, like if I compensate this, it'll undershoot. And so that well, you can make it worse, and that's really about as good as I can get it. This has a hex screw, but this flat tip can do that. Alrighty, so let's just see what it looks like. Here we'll go to acquire high res, and then we'll just, again, this has been in another video, but let's just see what kind of error we're going to get. We'll have math, dual waveform, and we have channel 1 set to 2, channel 2 set to 1. That's actually okay. We don't have to flip it, and that's subtracting, multiplying, dividing, adding. So this is giving us the error, and we can see what it's like to average that error. Put this knob here. So it'll take a while. So the error is got 100 millivolts per division, and so, you know, from peak to peak, looks like, you know, we're getting around 200 millivolts of error between. Anyway, that's as good as I can get it today. So to turn off math, just hit math twice or 3 times, and I'm just going to double check the sine wave, and then we'll get ready to do actually testing resistors, diodes, and transistors.